Okay, so today we're going to talk about network topology, right? And in the beginning of the first screen, let me just bring it to the. Oh, can I do this? Yeah, full screen. That's better. Uh, uh, there are different well symbols for different or different icons or symbols for different topologies for the network. And what we're going to do, we're going to talk about the basic topologies. It's going to be ring topology, star, inline or chain, and a bus network topologies. All right. So definitions. What is a topology? Well, topology is the arrangement of a network, including its nodes and connecting lines. So it's a physical arrangement. Well, is it a physical arrangement? We have a physical topology and we have the logical or signal topology, and we will talk about this. It's all going to be clear after we are done today. All right, so it's how the network is arranged. That's the topology of it. All right, now when it comes to, remember, see, network including its nodes and connecting lines. So arrangement including its nodes and connecting lines. What are nodes? Nodes are all the smart devices that are connected to the network. So for the most parts would be computers or PCs, wireless access points. We keep talking about that. We all should know what wireless access points are. And as you walk along our school hallways, you should be able to point them out. They're all over the place, right? Routers, switches, hubs, bridges, gateways, and whatnot. So these would be the routing, kind of a signal routing um, devices. And is it well, I haven't posted that yet because I'm waiting for the next class, and then after the second class, the second half of the class, they have the lecture of the first part, because this is the second part for you guys. Then I'm going to post the first lecture notes, and there should be link, or is it that one or is it this one? But in one of those lectures, this one or the one previous, there's going to be a link explaining what the difference is between hub and a switch. So at least you should kind of get the idea of what the differences are between switches and hubs. All the other ones, yes, I would encourage you to also find out what these are, because you're going to be installing networks. Not necessarily, this is not necessarily network setup course as far as the logistics and the logic of things, like a software type of setup. That's not this course. This course is about the cabling infrastructure, which basically involves also, in a big way, mounting racks on the wall and putting equipment into the racks and connecting them certain ways. So it's not just running a cable from point A to point B and terminating them at both ends. Uh, there's a lot more involved in this field, right? So other nodes will be printers, other devices such as, well, for example, IP cameras. Right? Then connecting links, because right, this is network topology, talks about the arrangement of the network, including its nodes and connecting lines. So here's the nodes. What are we connecting things with? Well, three basic things: copper, fiber, air. What's air? Well, it will be wireless access points, Wi-Fi. All right. So first, we're going to talk about something that's called a ring topology. This is a symbol for a ring topology. And what is it that I wrote here a couple of years ago? In ring topology, each node or host, so computers would be nodes or hosts, same thing. Each node or host connects to two adjacent nodes. So, well, that's how the symbol suggests. If this is a node, it connects to two adjacent nodes in a continuous pathway for the signal through each node. So the signal has a continuous pathway through the ring topology. Okay. Now, in certain type of ring topology, the signal can travel one way only. And in some other, and we'll talk about what that is, other type of ring topology, the signal can travel this way or can travel this way. So next couple slides, we're going to, or 2 or 3 slides down the road, we're going to talk about a little bit of a difference of labeling. Right? Data travels from node to node, with each node along the way handling every data packet. Each node acts as a repeater. So in a ring topology, this node has a message to that one there. And let's say the way of travel of the signal goes this way. So it says, well, here is a message for node number 5, blah, 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 right? And it sends it down. And this node receives that and it says, am I number 5? No, I'm not number 5. I'm going to pass it along. And this one here says, no, I'm not number 5. I'm going to pass it along. Same thing with this one. He said, oh yeah, I am number 5. Yep, got the message, right? So he's going to say, sometimes he's going to confirm the message that the message went through, and sometimes it is not going to. So here's the difference between reliable and unreliable transmission, data transmission. Okay, I'm just going to go off the topic just a little bit. What's reliable and unreliable data transmission? Unreliable doesn't mean that it's like it can't be trusted. It doesn't mean that. So there are 2 types: reliable and unreliable. So reliable data transmission, reliable data link, is that if something sends a message to something else, the receiver is going to confirm that it got the message. So it kind of slows down the data a little bit, but you get the quality if that's what you need at the with this situation. Unreliable data transmission would be something like broadcasting. Right? So the cable TV provider just shoots data down the pipelines, and whoever receives it. The cable TV provider, the digital cable TV provider, is not going to wait for confirmation for every data packet from the whole area of how many square kilometers that it provides for all the TVs. That would just clog up the system. So it just sends it, and the receivers receive it. And sometimes if some of the data gets lost, you're just going to see maybe a black spot somewhere on the screen. So the TV is not going to ask the TV provider to repeat that data packet, because it would just not happen. Right? So here's the difference between reliable and unreliable. So yeah, but back to the topic here. So here's a ring topology. Signal travels one way. Now, oh, my mouse goes backwards sometimes. For the network cards, and here's that. I posted something that's called single port NIC and 2-port NIC, or double port NIC. NIC stands for network interface card. Now, I just chose these pictures because well, they're big enough, and they're big enough for us to grasp. Now, excuse me, in the micro world of micro technology, those NIC cards still exist, or the NIC devices or NIC circuits, they still exist, but they are, for the most part, they would be interfaced. It will be integrated into the motherboard as a part of the motherboard, or the sometimes called the main board technology. Right. So, but this helps us with the visuals. These are still being used in the desktop PCs, but as I said, those are being built into the motherboards more and more often than not. But so for the so which NIC would you use for the ring network? Would you use a single port NIC, or would you use double port NIC? If you look at the way the signal travels, of course, we're going to have to use 2-port network interface card for every node, because you will have to connect to one on the left, and you have to connect to the other node on the right, or whatever the sides would be. Okay, so practically, you would have to have the double port network interface card. Is it possible to have a ring topology with just single port network interface card? Technically it is, but it's well, I'm going to present at the end of this slideshow, I'm going to show you how it is possible, but it would be just to prove the point, highly hypothetical situation, all right? All right, so ring topology hardware would be, for the most part, practical solution, double port network interface card for each node. Ring configuration, this is how the signal travels, so it's the same thing that this here, except you get a little bit more visual here. So the data keeps traveling in a ring configuration. Now, this topology was quite popular around late 80s, then 90s. So all the networks would be wired like that, not with the Ethernet cable, but the networks would be wired with something that's called a coaxial cable, either in the ring topology or sometimes in the bus topology. We'll talk about what bus topology is as well. Now, the computers or the computer network in the LAN configuration, for the most part, that with the world that we are mostly familiar with, this is not being used. That doesn't mean that this topology is not being used somewhere else. So you might see things like that in other configurations, such as maybe some industrial configuration when you can when you connect PLCs or other control systems. Some of them are configured to work that way, and some of them work just in a straight line topology, which we will also talk about. All right, I just want you to know that something like that exists. If you're going to install regular LAN configuration, which would be home running wires, and we talked about what home running is, then you would not use that. You would use something that's called a star topology, which we'll be talking about in a couple minutes from now. All right, so ring. Remember, I said in a ring topology, data travels one way. Well, here's the problem. What happens if something happens to this computer right here? It goes offline or it just gets broken in some sort of way. Well, if this computer wants to communicate with this one, it's going to have to send the data. And if there's a break in the data, so the communication is broken. Okay? If it just only goes one way. But notice that some of the arrows point both ways here. Yeah. Now, so what happens if it were a ring configuration, the data would just go one way, and as I said, the communication link would be broken if this one wanted to communicate with that, with data only traveling one way. But what can happen is we could have a different configuration. So if normally the data travels this way, and there's a break here, and this computer doesn't get a response, then it's going to say, well, if I couldn't send it this way, maybe I can send it the other way down the ring, and maybe this computer will get it. So it's a both way type of communication. And instead of ring configuration, we are talking about something that's called a token ring. So here's a ring, data travels only one way, and token ring would be the data is able to travel either way through the ring connection. Okay. Application, this is just an example of, remember we were talking about WAN. Remember, WAN stands for wide area network, and that's basically the, well, internet, okay, the whole World Wide Web. And then MAN, remember, metropolitan area network. So for example, this could be an example of a metropolitan area network that different buildings are being connected in various different ways. So some of the connections are made down through the fiber, some of them are made down through the air, okay? And you can see that the data can travel either way. So if any of those goes online, it doesn't affect the whole thing. So this would be something that's called, if you erase that line right here, oh, well, you have a ring configuration here, and you also have a ring configuration here. So it's a ring within a ring. Well, who says that you can do that? Why not? You can connect things whichever way you want. So one thing that, remember, we'll talk about uh, something that's called media converters, or media players, or media converters. This will be a media converter converting the electrical signals from the data Ethernet cables into the electromagnetic waves. So here will be a media converter, and here will be a media converter, converting things both ways. Also, the copper wiring would be connected to all the PCs, computers, and all the nodes. And we would have another media converter here, and another media converter here. And this type of media converter would be to convert the electrical signals into the fiber optic signals, which would be light pulses. All right. Yeah. So here is the difference between a ring and a token ring. Okay. Ring config. Okay. My mouse sometimes I push it forward and it goes backwards. Figure that out. All right, so applications for a ring, another applications for a ring configuration. Well, here is a switch, switch 1, switch 2, switch 3, switch 4. Well, if you have regular LAN configuration, you would be running the cables, the Ethernet cables from the field jacks. And field jack is a jack somewhere in the building, could be a desktop, could be jack in the wall, could be jack in the ceiling. It's called field area, all right? And so all the cabling from the field area home runs to the LAN room, and it's terminated in one-to-one dry termination from one jack to another jack that is on the patch panel. And the patch panel is basically a bunch of jacks stuck together in a frame, so you don't have to disperse things. So it's to save space. All right, and those are being plugged into a switch. One-to-one switch. One port from the patch panel plugs into the one port on the switch. And this switch basically directs the traffic, the Ethernet traffic that's within a LAN. Well, what happens if because you could have, well, you can have 8-port switches, you could have 12-port switches, you can have 24-port switches, you can have 48-port switches and whatnot. But what if there are so many computers in that area that one switch is not enough? Then you're going to have to add another switch, and maybe another switch, and maybe another switch. And those switches, they have to act like one huge switch. So you would connect them in a ring topology. Those switches would be connected in a ring topology, so they work as one big switch. So all the data is being directed, and I don't want to use the word routed or routed because switch is not a router. And the router is some other different device, but the traffic is being directed. The Ethernet traffic is being directed by the switches, and there's some other functions of the switches that you can have permissions or restrictions and all that stuff that goes with it. So yeah, so here is an example of using a ring topology. So these 4 switches are connected in a ring topology. See, they don't have to be in a circle. They could be one on top of the other, and they are connected in a ring topology. Okay, good. I think we got it. All right, there you got it, Mr. Buck. All right, here, oh yeah, these are the links. So once I post that, here's a YouTube link that is, sometimes I search for those helping videos. Some of them are made by me, and some of them are made by whoever I can find that I find that are interesting and reliable and good. So here are 2 videos. One is, well, 7 minutes and 21 seconds. And this one talks about hub, switch, and router, explain their differences between those two. Please watch that video, because when you are going to do installations or service calls, you need to know, even when you're talking to some tech support, they're going to ask you to connect to certain things. They're going to ask you to, touch certain pieces of equipment, remove, replace, or whatnot. And if somebody has to explain to you what a switch is, or if somebody has to explain to you what a hub is, then, well, it doesn't put you in a very good light. All right. So please do yourself a favor and watch this video here. Now, here is another video. This one is a long one. However, I'm going to ask you just play 1 minute and 42 seconds of it, because later on this guy talks about some details of how to set things up, and it's just not very useful for us. But in the first minute and 42 seconds, he shows the switches being connected in a certain way. So it will be ring topology or line topology. Okay, so these two videos, please click on those once you get it and watch that. All right, now from the ring topology, we're going to move on to something that's called a star topology. Well, it looks like a star, like a starfish. Was it SpongeBob SquarePants star, kind of a whatever this guy is called. I forgot his name. Patrick. There you go. All right, it looks like Patrick, right? Star topology. Well, what do we have here? Each node, and node, we know what nodes are already. Nodes or hosts would be any smart device, such as computer, printer, whatnot, anything that connects to the Ethernet. Each node or host of a network is attached to a central node. So there's one central node, and all of these home run to it. So this, when installing the LEN configuration, this would pretty much be, well, I would say almost pretty much 100% of all the way of running wires would be home running those wires to one of the central points. What is the central point? Well, central point would be a LAN room or equipment rack or distribution frame. And what do we have? Distribution frames. What kind of distribution frames? We have a main distribution frame or IDF, which stands for intermediate distribution frame. So in a star topology, all wires home run, all roads lead to Rome. Right? So it's called a star topology. The central node is usually a hub or a switch. Oh, well, you know what? Here it is. Okay. The central node can also be another proprietary device. It doesn't have to be a hub or a switch. Like, for example, such as NVR. And NVR stands for Network Video Recorder, or sometimes they're being referred to as DVRs, which would be a digital video recorder. And it has to do with the security cameras, video surveillance system. So sometimes the cameras are being connected straight to NVR, network video recorder, or DVR, digital video recorder. The NVR and DVR are, well, for the most part, they are the same thing. It's a box with a bunch of smarts in it, and it has a bunch of ports, Ethernet ports, to which you connect the security cameras when they're the IP cameras. And now the IP cameras, internet protocol or internet protocol cameras are the ones that are being pretty much sold on the market right now. If you have some of the old analog cameras, you can still find them, but it's just to accommodate replacement of some of the old systems, and you can find them less and less anymore these days. All right, so DVR, digital video recorder. Well, first was TDR, which would be time domain recorder, and would be a VCR, which is it would be a kind of more sophisticated VCR that would let you to chop let you multiplex the views from the cameras very fast. So, and they would be played very fast, synchronized from the tape, that you could just see the kind of almost like a strobe light action on each camera, and the quality, the picture quality would be less the more camera you would use, because you would be circling around the camera, but very fast. Right? Then later on, DVR came on the market. It will be digital video recorders, and technically digital video recorder was basically a digital video recorder instead of the VHS tapes. So not necessarily it would have the Ethernet connection. However, that was for a very, very extremely short time, because all the DVRs are equipped with the Ethernet port, so you can connect it to a network. So then they started calling it the NVR, network video recorder. But if you want to point a clear difference between what an NVR and DVR is, you're going to find people using the term interchangeably. All right, so the NVR or DVR would be the central node, and all the cameras would be connecting right to it. Just plug it in, plug it into the port, plug it into the port, plug it into the port. It doesn't have to be a switch. Now, what you can also do with the security cameras, there's a common practice that is being done. There would be a switch somewhere in the field, and all the cameras would be plugged into the switch, to the switch, to the switch, to the switch, and that switch would be connected to one of the ports of the NVR. So that is also a common practice. Well, sometimes it is, but the only thing is that when you get those small systems with the security cameras, if you plug them in straight into the NVR or DVR, if you can do that, then you don't have to do as much setup. But if you plug those cameras into the switch, and the switch is plugged into the one of the ports of the NVR, then you have to do some extra setup of assigning the IP numbers and addresses and whatnot, so the NVR knows what to look for as far as signal. Okay, so there is a star topology, and here's a statement and a half. A star topology is the most common physical wiring configuration considering horizontal network wiring. There you go, Mr. Bach. First, you explain something, and every time you explain something, you leave some, you create some other unknown. All right. All right. So star topology, that's what it would look like, sort of, right? Here's a switch, and here's a bunch of computers. Okay, not much to explain here. Star topology in the LAN local area network, right? All cables home run to one common point, and in the real world, this is what it looks like. All these cables, each of those cables is terminated on the patch panel, which is basically a dry connection jack that's on the other side of the patch panel, and each cable runs somewhere in the field. So it could be to a desktop, or it could be jack in the wall, it could be jack in the ceiling, and that's basically what things look like. A lot of work sometimes, and it's an art too. Star topology locally, that's what things look like from the other side. So over here you would have something that's called a patch panel, and you can see they're just numbered. So this here, that's the back of it, the cable is connected, terminated, and this over here is the other side, that's the front of it. And from here you use patch cords to connect things to a switch. So for example, these yellow patch cords are connected to a switch. This is a switch, because you can see the lights flashing and all that stuff. And those are connected with the patch cord somewhere to the patch panels or maybe some other devices. Right? So that's what the star topology. Well, installing networks, you just run the cables, you home run them, terminate them, certify them or qualify them, give the documentation to the client, take a bunch of pictures, just like we do in our labs deliverables. I'm getting you to, practice following the instructions to the T. So they're going to make your life easier once you find the job. And somebody is not going to have to teach you how to, well, maybe they're going to instruct you on how to do specific tasks. Maybe they want the deliverables a certain way, but you get the idea of producing deliverables. It's not just because I want to, or we want to, because, to satisfy some sort of ego or something like that. No, this is what you will be doing. So we're getting you ready for that. All right. All right. So remember when I said, star topology is the most common physical wiring configuration considering horizontal network wiring. Okay, what's horizontal network wiring? All right. So here is some kind of a concept diagram of a network being wired. You have floors. Here's the ground floor. Here's another floor, first floor. Here's a second floor. All right, and so on. Here is what this thing was labeled as main cross connect. Sometimes you can call it a demarc point or demarcation point, and demarcation stands for point of entry. So, well, there's going to be one location that everything comes to from the outside. And over here, usually in local businesses, if you go to Toronto or London or any bigger city, when you see those business high rises, or if you have hospitals, schools, and other buildings, quite often you're going to see that the land rooms or the sub land rooms are arranged in something that's called a riser configuration. So if there is a communication closet or a LAN room on this floor, quite often, almost always, you're going to find that another communication closet or a LAN room for the floor below is going to be directly below that one. It makes things so much easier for installing things and running the communication wiring and whatnot. So over here, this would be considered something as a riser. And it's also will be part of the backbone. Just like animals or humans, we have the backbones. So this would be considered as a backbone. The backbone doesn't have to be a riser. A backbone can be a switch or a router or a modem or something that's a so-called internet box that you get provided by your internet provider. And it has the connection to outside, and it has ports to connect to whatever LAN connections you're going to connect, LAN type of connection, which would be your PCs or some other wireless access points. And sometimes that so-called internet box has wireless circuitry integrated in it. All right, so that box can also be considered as a backbone for your network at home, right? Or the backbone can be considered as the main cross connect, and then as far as the riser, so this would be considered as a backbone or a riser. Where's your riser? Here's the riser. Okay. Now, from the risers, you're going to have individual field wiring that goes to each individual floor. So here, all the connections that are connecting to this distribution frame, which is part of the riser, are considered horizontal runs. Okay. So here will be horizontal runs that have to do with this floor. Here will be horizontal runs that have to do with this floor, and so on. Notice that, okay, in this one here, in this picture, it was labeled as telecom closet. So you're going to see terminology like that as well. For the most part, you're going to ask, where is the LAN room for this floor? Where is the communication closet for this floor? Where's the telecom closet for this floor? Telecom closet, well, telecommunications, so that's fine too, right? So here are the horizontal runs, and here is the riser, which is part of the backbone. Okay, so again, in a star topology, the star topology is the most common physical wiring configuration considering horizontal network wiring. There you go. These are connected to that communication closet in a star topology, which means every computer, every smart device home runs to the central location. What would be the other way as opposed to home run? Well, it would be one wire there and connected to the first one connected to the second one connected to the third one. It would be like daisy chaining things or running things in line. And LAN configuration, when you're doing buildings, offices, schools, or whatnot, you'll be doing the star topology. And that's basically what it looks like. Star topology. Most popular physical cabling topology is the star topology when you're running things. What do we have? We have computers terminated at the patch panel. Patch panels are one-to-one patched through the switch, and switch is connected to other signal directing devices and processing devices. Yeah. All right, now here is something that's called a bus topology. The bus topology was used instead of the star topology, well, not instead of the star topology, because it was used before the star topology was used in local area networks. So there would be one central node, or maybe not even one main kind of a communication computer. You could connect a bunch of computers with each other through something that's called a coaxial cable, and those would have connectors, and there will be taps. So everything will be tapping in, tapping in, tapping in, tapping in. So that's, here is the main signal wire, and everything taps in, everything taps in, everything taps into the signal. And by using different communication protocols, the whole thing can communicate with each other. This was the old way of doing it. It was pretty much done mid 90s. It was that type of thing was abandoned on the account of the star topology. Okay. Does it mean that the bus topology is not used anymore? And what's a bus topology? Okay, all devices are connected to a single cable or line. Things are being tapped in, tapped in, tapped in. Bus topology was used, well, I should change this date here. Basically, that's what I said, early or mid 90s. Right? Then the star topology took over. Does it mean that the bus topology is completely abandoned? No, it is still being used in other devices. All right. Here are a couple of examples of where bus topology is being used. First thing on top is something that's called a fire alarm configuration, which would be the very simplistic, quite simplistic explanation on the basic explanation on what the bus topology is. And here is a security alarm, which also uses bus topology to communicate some signals to communicate some devices together. Right? So how is that fire alarm work? Here is something that's called a zone. A zone is one of the circuits on the main panel. So the fire alarms can have many zones, and zone is basically a terminal, one circuit to which you connect a loop, and that loop can be designated to smoke alarms, all the smoke alarms in that hallway. The other loop, the other zone, can be connected to, well, all the heat detectors in certain part of the building, and so on. Okay, so this is one of the zones, and the zone is a loop. So it acts as a bus because everything is tapped in. It would be a device. It could be a smoke detector, it could be a heat detector, or it could be a pull station, or it could be some triggering device. Those devices are normally open. So under normal conditions, when nothing happens, the zone doesn't even see any of those because they are connected as normally open devices. They have a bunch of circuitry that is designed to sense certain type of condition, for example, a smoke present, heat present, and whatnot. But on the output of it, there is just a dry contact. And when it's idling, that dry contact is open. So this here is not even seeing, this zone is not even seeing those. At the end of the line, you have something that's called an end of line resistor. And the resistor's value could be different depending on the system and manufacturer and model or whatever. So under normal conditions, the zone is going to look for the end of line resistance. It's going to look for that value. And if it sees that value, it's going to say, whoop, yep, I am good. Nothing is happening. So everybody at ease, continue with your day. If the line gets broken somewhere, then that zone is not going to see that resistor anymore. And it's going to go into something that's called a trouble condition. It's not an alarm condition. It's called a trouble condition, which means that there's a trouble on the line. So the system might not work as it intended. So if there's a fire, it might not be detected, right? So, and then it's going to produce annoying beeps at the panel that people who are in proximity, they're not going to be able to concentrate or work with it. They're going to look, where are those beeps coming from? And it says, oh, trouble, a fire alarm trouble, call this number or something like that, right? So they're going to call this number so this thing shuts up, right? So if there is a condition, fire condition, or like, for example, this one's, let's say this thing here detects a smoke, it's going to close the circuit, so produce dead short across that. So the zone is going to see a dead short and it's going to go into alarm condition. So here's an example of a bus configuration, bus connection, but it's a very simplistic one. Now here is a security alarm, and look at this. Oh, come on. There we go. Here is a terminal that says bus. It actually says bus. So each keypad would have 4 wires connected. I didn't draw the other ones. The other ones would be red and black. And they will be connected to the power, auxiliary power. So they will be connected to power up this keypad, plus and minus, and they also be connected to this keypad, plus and minus. But also the communication port on each keypad is connected to the bus terminal. And notice they're not home running. No, they're just tapping into the bus. And there are different communication protocols being used that these can communicate with the main panel on individual basis just by using the same connection. So here is a bus topology that's being used. Couple of examples like that, all right? Okay. Inline topology, we're cutting close to the time, so if you have to go, but then make sure that you catch the end of it on YouTube when I post it, right? Inline or chain topology. Well, look, these are ring, this is connected in a ring topology, these 4 switches, and these 4 switches are connected in, there you go, inline or chain topology. So from here to here, from here to here, from here to, that's it. So if this link gets broken, there's no communication between this device and that device. In a ring topology, well, you get kind of the whole thing connected into a ring, so data can travel anyway. And it would mostly be a token ring kind of a configuration, right? This inline or chain topology, you are quite often going to see in some control systems, industrial control systems, well, that have to do with controls, PLCs and whatnot, in factories and plants and whatnot. And those control devices would be would be proprietary. It would be assigned to whatever it is, the equipment, and you're just going to run Ethernet cable from one to another, from one to another, from one to another. Not necessarily connecting all the devices in the ring configuration. Inline or chain topology. So sometimes I'm going to show you some of the real examples of real equipment. So that is going to give you a little bit of more knowledge, and it's going to make you more valuable and employable if you know what the equipment pieces are. So this is not a big philosophy. Here we have a switch, and here we have a switch. We have a laptop and a printer, laptop and a printer. Well, you haven't learned any new terminology. Everybody knows what laptop is, and everybody knows what a printer is. Okay? But these two in this here, they're connected in a star topology. Right? Quite often, the printer is being connected. It could be one big, very expensive printer and connected in the office environment. So if somebody needs to print some documents or whatnot, they will going to send the file to the printer over the network, and that printer is going to print those documents. So this printer would be common to, let's say, maybe 20, 40, 50 computers, because not everybody prints at the same time. This one here, this printer is connected in line with the switch. So these two devices are connected in line topology if somebody wants to have a dedicated printer in their office, right? So here's star in line, okay? Well, here is something. What is it? The Ethernet extender is connected. So I'm giving you examples from the real life. Ethernet extender is connected in line with the Ethernet link. I keep talking about the maximum length for the copper wiring. And no matter what specifications you get, sometimes you're going to have a more sophisticated link and sometimes not as such, which means you can send data faster or slower through that link, depending on what cable you use and depending on what length. But when it comes to copper, you're not going to exceed 328 feet end to end. And for the most part, we're going to say we can't exceed 300 feet. You want to reserve a little bit of a slack for connecting the patch cords and patch cables and whatnot. So leave that. So 300 feet end to end. If the length is longer than 328 feet altogether, end to end, then you're going to have problem with the data transmission. You're going to, if you exceed it a little bit, maybe 40 feet or something like that, you're going to have some intermittent connections. Some of the data is not going to get through. If you get longer, then you're just going to lose the communication completely. But what if sometimes you need longer distance and speed is not the most important thing? Like, for example, a cash register in a store. You don't need a speed in order to communicate the transaction that somebody bought the chewing gum. You're not sending the HD quality picture of the chewing gum to the mainframe. You're just sending a couple of numbers that say, okay, it costed that, it was purchased at this date and this location. That's it. It goes there. So it doesn't, the speed is not the most important thing. But you have the distance between the switch and wherever the cash register is, that's longer, way longer than 300 feet. And you still need to have this thing connected. Well, you would connect something that's called the Ethernet extender. So you get 300 feet from here to here, and you might get another 300 feet from here to here. The data is not going to go as fast because it's going to have to be processed and boosted and repeated and sent that way. And from here, processed and repeated and boosted and sent that way. But at least you're going to have a clear, reliable communication. Right? So here's a common thing. Now, the Ethernet extenders, they have to be powered. Right? So you could plug it into a local hydro outlet through a little power supply with transformer. But what if you don't have an outlet available? Well, you call an electrician, and so they can install it for you. Well, what if you can't? Well, there's another solution. This one here, it says this PoE injector is connected in line with the wireless access point. Same as the Ethernet extender, it needs power. The wireless access point needs power. If you have something to plug in the ceiling, you just get a little power transformer, and if that has that kind of an input, power input, then yeah, you're laughing. But what if it doesn't? And most of the time it doesn't. So the Ethernet ports transmit signal back and forth. That's their main function. Well, sometimes in some of the equipment, the Ethernet port also has power coming out of those jacks. And the purpose of that is to carry the power signal over the line so you can power up the whatever the device is. Notice it's just going to plug in the Ethernet cable and that thing comes on, because the aside from the signal circuitry going to that port, there's also a power circuitry, and it's putting power on the certain pins, and that power can be used. So now there are different specifications, different voltage. 48 volts is the most common, but sometimes there are different voltages, and there are some different combinations and different power ratings. So I'm not going to talk about that. But if the switch, because there are switches that have that power, those jacks powered, and some of the switches have just the jacks that just provide the signal with no power. PoE sends power over Ethernet. So if you have a huge project that you're going to get all bunch of telephones, VoIP telephones that need power from that or whatnot, then the client might decide to replace the switch with the one that is capable of jacks with the PoE in them, power over Ethernet. But if sometimes it's just the whole system works and it will be just too big of an operation to just add one device that needs PoE, you can use a device that's called PoE injector. And yes, you have the hydro to plug in, but this will be going in the rack location, and there's all kinds of power outlets in the rack location. So instead of going from here straight to the device, you're going to this PoE injector, and from that PoE injector it goes to that. So signal is being transmitted and the power is injected into it. Yeah. All right, another one, VoIP telephone, voice over IP telephone. This VoIP telephone is connected in line with the workstation computer. Quite often when you're adding when companies switch from regular telephone or the what I call the conventional telephone systems, and they add the VoIP telephone system, you can't use the VoIP telephones over the regular telephone lines that they had previously. So they are going to have to need their network connection provided to their office. And usually they already have that because they have the PCs connected to the network connection, unless you have Wi-Fi. Right? So instead of adding one more wire, one more Ethernet cable, you can connect that phone in line with their PC. So the client still has the PC running as it was, and it also has the telephone running as well, it will, right? So the cable goes to the telephone first, and there's a port that's labeled input, and there's a port labeled output. So from here to here, from here to here, so that VoIP telephone is connected in line with the workstation. Right? All right, so now we're going to go back to one of the first slides as far as the physical and the logical or signal topology. I just want you to know the difference. This is a highly hypothetical situation. Consider PC0, PC1, PC2. Where do we have the PC0, PC1, PC2? Here's a PC, here's a PC, and here's a PC. So consider these three computers. Right? Are those PCs connected to the switch in a ring configuration, or are they connected in a star configuration? Well, physically it looks like a star, and it is because the cables are run this way. But can this system work as a ring? And if yes, how? Yes, it can work as a ring hypothetically if this here is set up for signal routing in a ring configuration. So the signal will go, I don't know why somebody would do that, but it is possible technically, hypothetically, that this. So I just want you to, the reason why I'm doing this is I want you to see the difference between the physical and the logical or signal topology. Right? So let's, if you imagine there's a switch and a bunch of computers are connected to it, depending on how it is configured internally as far as signal routing, it could work as a star, it could work as a ring. Again, highly hypothetical situation. All right. And this would be how the signal would travel in the ring topology. You know, lab foundation. Another thing. Here's a patch panel. Here's a jack. Here's a patch panel. Normally, we're going to connect the cable from one end to another, so you could use two jacks. So this will be the field configuration. In the LAN room, you could have a bunch of jacks on the wall, but it's not very practical because you would run out of space very quickly. So if you put those jacks in a frame beside each other, you get something that's called a patch panel. Here goes the mystery solved. Here's the color code of the jack: blue, orange, green, brown pair. And you would follow different jacks have different arrangements at the back. At the front, they're all the same as far as connection. And at the back, they could be constructed in a different way. And the color code is marked on which terminal is which as far as the color code for the cable. And on the patch panel, you have the same thing, except for this one here is maybe that one at the back. This one here is number 2 at the back. This one here is number 3 at the back. So you get the same thing, but transferred into the patch panel configuration. Okay. Insulation displacement connection. This is what we do in the communications. You can read the history of it or whatnot. What's an insulation displacement connection? You have a wire that is jacketed. If you push that into this type of connector that is kind of spring-loaded inwards, and you just have to shove that in with some sort of power, physical power, that connector is going to bite into the insulation and make connection with the copper wire that is inside. So that's why it's called insulation displacement connection. Much faster than soldering and quite reliable. Right. Now, there's one thing that I left here. I thought about correcting it because I found this picture on the internet. Here's your reference. Somebody put that as a stranded type of wire. Insulation displacement connection is not for stranded type of wire. If you do that to the stranded wire, some of the strands might be broken and you're going to lose the thickness of the cable. You're going to lose the specifications of that conductor. That is for solid conductors only. So whoever did that, it's a good idea to put this thing here, but I left it just so I could mention that. Don't punch, do not use stranded conductors for insulation displacement connection, except for one thing, and it would be in the patch cord. When you connect when you crimp the Ethernet jack on the cable, the inline jack, the modular jack, some of the connectors are designed because it's also an insulation displacement connection. That connector bites into the wire, bites into the insulation and makes a connection with the copper wiring. And if you have a solid wire, you're going to use certain types of jacks that are designed for solid wire when you crimp those jacks. And if you use a stranded wire, which patch cords for the most part will be stranded wire because you need the flexibility. That's the, that's the thing. Then you need to get those jacks that are designed. They are just shaped a little bit different. Those connectors have different shape to bite into the conductor and make a connection with the copper wire that is stranded inside the conductor. Okay. But when it comes to patch panels and whatnot, we're not going to use stranded wires to connect it to jack like this. The other one I was talking was a plug. Okay. Jack like this, they are designed for solid cables only. And we're going to terminate both. We already have started lab 2 with some groups. So that will be insulation displacement connector for the modular plug. And we are using the solid core wiring, and we're using the solid core jacks or the plugs that are designed to handle solid core wiring. Right? That's pretty much it for today. That was the last slide. Cool. If you have any questions, by all means, send me an email. Other than that, I'm going to see you next time I see you. And if I don't see you before the weekend, have a great weekend. Thank you, guys.